Just a quick bit of theory today, actually, and that's a bit on, well, continuity. Continuous graphs. What are continuous graphs? Well, a graph that doesn't have any vertical asymptotes, such as, the hyperbola would not be a continuous graph because it breaks at x equals 0. Point discontinuities, you get some of those graphs where there's just a point missing, or any other gaps, right? If it doesn't have any gaps, then we say it's continuous. So some examples, as I was saying, classic one is our hyperbola, of course. So there was this sort of one as well, where you have x on x, which you would think is the line y equals 1, but of course x can't equal 0 for that one, because 0 on 0 is not actually equal to 1. So you have a point discontinuity. And some of those split graphs where you have different functions depending on what the x values are. So they're all discontinuous graphs. Well, what's important about that is differentiability. Right? We only perform our calculus on continuous graphs, or where the graph is continuous. So a function is differentiable. Geez, some big words today, eh? Differentiable if the curve is what we call smooth continuous. So there can't be a gap at that point, but also you can't have sharp points, so like the absolute value graph. So at x equals 1, everywhere else it's fine. Parabola on its side, so x equals 0, again, can't do it. To the right-hand side of it, you could. Anyone know what that's called? So that's a cusp. But again, at x equals 2 there, you got a sharp point that it comes down at. So no good, you couldn't differentiate at that particular point. Okay, so just a little bit of theory today. Handful of exercises. Enjoy.